Hey, Sudhir.
Hey, Judy.
How are you?
I'm good.
All right, you are right on time. That's very good. I like people who are on time. Let's give everyone a few minutes.
Yeah, sure.
Desh is there.
You have all these anecdotes about how they thought it was a spoof because what is presented doing it?
Is Akshat joining in? Does anyone know? Hey, Sishir, can you ping Akshat? I need him to join in on this one.
Okay.
What's up, Todd?
Yo.
What's up, Todd? How are you, man?
Yo, how about now?
Yeah, I can hear you. All right.
Cool.
He's joining. Technical issues.
So I'm just waiting for this one more team member of mine. So Duke is like, oh, it's too early for me. I'm like, you know what? Get out of here. Like, I told him, I'm like, next time don't ask me questions or don't ask me to like say, oh, do software sessions when I actually set it up and it's like too early for you. Like, get out of here. That's bullshit. It's 11 a.m. You can just pick a cup of coffee like you did and spend 1 or 2 hours sitting listening. It's not that hard. Anyway, all right, Akshat is there. This is great. I'm going to join from my room as well.
Hey, wait, are you serious about expecting this to be 2 hours?
No. We'll stop when we will stop, right? Like, we don't have to. We don't have to.
Yeah, isn't it like the middle of the night? Are you guys all in New York, or is anyone here overseas?
Oh, actually, yeah. Let me tell you. Sudhir, say hello. Sudhir is in India. Ritesh, say hello.
Hey.
He's in India. Akshat and Sushir are in New York.
Hey.
Cool, hey guys. I'm Todd.
Yeah, by the way, yeah, sorry. That's my very, 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 very dear friend Todd. Great guy. He's been working on the risk side, but he loves technology, and we often geek out about technology. So I thought, I will ask him as well. And Sudhir and Ritesh were with IVP. Ritesh is a great kid. He decided that IVP sucks and he went somewhere else, but he wants to. When I thought about this, I'm like, maybe he's still interested because he did enjoy the session when I used to take it at the Alpha Dime. Anyway, so the part of the thought process behind all this session is going to be, we're going to start from some fundamentals, right? And then we'll actually move on to more engineering concepts, right? We all are been writing code. We sort of understand the basics, right? Like, hey, there is a for each loop, there is dictionary. So we are not going to go into that aspect, right? What I would really try to go into is what I think is some of the things that a lot of developers don't really think about that much, which sort of limits their ability to write great code, right? And what I'll seen is you sort of write code and you sort of think that this is how it works, but not fully. And I think that sort of limits your ability. So and that is where when we talk about C# as a language, right? The first thing in terms of really getting good at the language is sort of understanding, hey, what does a compiler do and what does a runtime do, right? That is something which should be absolutely crystal clear in your head, in my opinion, right? So we all have heard the term called CLR, right? Common Language Runtime. Oh, 1 second. Is it recording? I want to make sure I'm recording this.
Yes, it's recording.
Okay, perfect. I did set up the setting that whenever this meeting is started, is recorded because I don't want to lose the session. So can anyone here very clearly articulate what CLR does? And why was it created? What's the purpose? What is the problem we are trying to solve? Okay, so let me sort of share some history about how we came to the world that we came into, as in like from a programming side, not from a philosophical sense. Okay. Can everyone see this? Okay, so computers were invented. You have a CPU, right? And you would have heard this thing called x86 or x64, right? What those things are is what we call an instruction set, right? That is, a CPU defines some primitive instruction set as to, hey, how do I add two numbers? How do I give you register? And stuff like that, right? That's the basic premise. So then how do you talk to this guy, right? So very first we came up with assembly. Assembly as a language, right? And we'll say this is the level 0, right? So there you have assembly instruction like move, A, B, something like CMP to compare and stuff like that, right? And that is how we used to write programs back in the day, right? So if I were to put different layers, right, you have at the end a CPU, and level 0 is the assembly language. It pretty much speaks directly the instruction set of, hey, move this data, compare this data, add some data, right? And obviously, that doesn't make it very easy for us to write program, right? Because not everyone is that level of, not everyone has that level of expertise, right? So then we came up with the language called C, right? Where it became somewhat of human readable language, right? That is, hey, I will be able to write something called for I equal to 0, like a for loop, right? And then you have a compiler which will take this English words and translate into assembly language that the CPU can run, right? Then we came to the next level of, okay, this is sort of good, but all you have is the notion of fields and methods, right? And this is very important part about it, right? What does it offer? Right? That it offered you fields and methods, right? And that's something that you can sort of relate with, that, oh, it's doing fields and methods, right? Now that was also good, but again, it's like, then you're like, okay, I still cannot express what I want to express in terms of solving my business problem. So we came up with, say, C++ language, right? So it is also human readable, but it offered a notion of a class and OOP to sort of encapsulate what we really want to solve for, so that we can focus on solving the problem and not worry about the nuances. Now there, the biggest limitation was, hey, like you still have to know quite a bit, right, about computers to do this, And one of the biggest challenges, memory management, right? You have to worry about memory management here, you have to worry about memory management here and here, right? And if you think about CPU, right, CPU also has, CPU has registers, right? And CPU has L1, L2 cache for performance reasons. And then you have actual RAM, right? And if you remember back in the day when we used to have 16 MB RAM, 32 MB RAM, right? So that time you have to worry about that in your program, right? Because you don't have infinite amount of RAM that you can just, will use and your program will run. So that is where this languages we were not evolved in computer science, so you had to sort of worry about it every time you write program, right? Now, out of all the things which have been painful till the world of C++, one of the biggest pain point is memory management, because it is extremely hard, right? You have to really know a lot to be able to manage memory properly, right? Now that obviously, the more something is hard, fewer people will be able to do that, right? So super smart people came up with, memory management languages like Java and C#, right? So their biggest selling point was memory management, right? And that is what really opened up the world of programming to, normal humans like you and me, right? So we can say a whole bunch of them, right? Java, C#, Python, whatever. So the biggest thing they offer is memory management. Does this thing make sense so far? Right? So here, what is one of the main difference between this tree and Java, C#? And I'm going to skip out Python because that's a whole another topic of discussion, right? That for this tree, right, whatever compiler produces, right, right? And this one, what we call either uses a virtual machine or what we call a runtime. And that's a very, very important distinction, because to be able to do this memory management, right, and memory management correctly, you need to introduce a layer in between. A layer which will take that memory management burden off of you, right? Now, why you need to introduce that layer, that is going to be like, we can do another 1 hour session if you really want to get into it. But for now, let's just take it at a face value that we need to introduce this layer. Otherwise, we can't offer memory management, right? And that is what originally Java did. And in a way, actually, I would actually separate it out in two ways, right? Java has Java Virtual Machine, JVM as we call it, and C# has Common Language Runtime. And one thing that a lot of folks will gloss over is that there is a difference between these two. They didn't call it, say, Common Language Virtual Machine. They called it runtime, and that distinction is very important. In Java, when you write program, it actually runs inside what you call a virtual machine, and that virtual machine will translate your Java code into assembly language so that CPU can run it. C# doesn't really have a virtual machine, it has a runtime. And what I mean by that is this. I woke up in the morning and I was thinking about it, okay? You have all heard of a garbage collector, right? Can someone tell me if the garbage collector is per machine or per process?
I think it's machine.
Right. Okay. Anyone else?
I was going to guess, JD. I would have called it machine too.
Right. Anyone else? Oh, Paz.
Yeah, I'm here. Just kind of. Yeah, I'm just. I got the kid here, hopping on and off. Yeah.
All right.
So,
per
good to see you, man. Been a long time. Glad you're alive. All right.
I am. Oh, you're talking about Todd, yeah.
Yeah. Okay.
Anyone else? Todd, what do you think? Garbage collector, you heard the term. What do you think? Is it per machine or per process?
It would be a pure guess, so I don't even have a guess.
Okay. Akshay said, okay. Ritesh?
Yeah, a calculated guess would be pure machine, but I don't have anything to prove that point.
All right. So it is actually per process.
Yeah,
Garbage collector per process. Okay. And here's the funny part, right? It seems like garbage collector is per machine, and it would be per machine if it was a Java virtual machine, but we don't have .NET virtual machine. We have .NET runtime. So that's the main thing. So what happens actually, right, at a high level? So what geniuses at Microsoft designed is something called MSIL, which stands for Microsoft Intermediate Language, right? And what you do is you go from C# to MSIL, right? You give it to the runtime. It converts it into actual machine code along with other things that your program needs. So what do I mean by that? Let me see if I can help you visualize that. So let's say you wrote your C# program here. Okay, so this is your C# program, right? So then the compiler will take it and turn it into MSIL, right? Now you come to your, let's say your Windows runtime, right? Now when you actually run it, whatever that exe you produce, right? And whatever the DLL you produce, Microsoft has put in things in there to detect that it's a .NET exe, okay? So when it detects that, then it will try to find the .NET runtime. So I don't know if you know, there's something called mscorelib.dll, one of the DLL, which is the core .NET runtime. And there are a bunch of other DLLs, right? So there are some core .NET runtime DLLs, right? So the Windows detects it, that is a .NET assembly and not a pure exe like what you get out of C language. Then it hooks those things in, right? And then the logic here converts this into actual assembly instruction, and you would have heard of a term called just-in-time compilation, right? And it converts it into executable code, and that is what runs. So actually, each process that you run has a runtime and has a garbage collector and has the permission system, everything running for that exe to run. Does that make sense?
Yeah, the stuff you just said, that applies only to the executables which were built using .NET, right? Not the other stuff.
Mm-hmm.
Okay.
not the other stuff. So I'm strictly speaking about .NET, right? Now, that is where if you've done Java in the past, right? Java produces jar files. And then you put Java and then you give a path to your program.jar. You see how that is different, right? Versus here, it produces exe, right? So let's say your program was called myprogram.exe, right? When you compile it, each exe has like headers and stuff like that. So when you double click it, Windows knows, oh, this one is, you know, a .NET exe. Then it will sort of do some magic. And obviously, I don't know all the magic that happens. I know magic happens. It will pull in different services, pull in the runtime, pull in the libraries, and, you know, give you a garbage collector, give you this, give you a just-in-time compilation, and then it will run your program. Okay. So
Judy, so then is there yet another step that it ultimately, after the Windows runtime step, it will then convert that into the final lowest level, like assembly code?
So JIT will produce that this runtime will know how to take this MSIL and produce into assembly. And that's the final step. That's it. There is no more step after this. This one will do whatever is necessary. And the reason they call it just-in-time compilation is like this is so this is actually called JIT compiler. So not only you have like C# compiler, you also have a JIT compiler. What does it do? It converts MSIL to assembly that CPU can run. Right? So think about it. What is actually happening at a high level? Try to visualize, right? C# compiler, MSIL, compiler, and assembly. This is the level I was talking to you about. And then
just for, sorry, just like for comparison then, like does Java have one less step, or is there an analog for all those things in like the Java space as well?
So I would not know that because I didn't really spend that much time on Java. So I wouldn't know that. I can speak more comfortably about .NET world a little bit better because I spent quite a bit of time on that. And that is where, right? And the reason they did it this way also is that this MSIL, right, Microsoft Intermediate Language, is a common construct they have defined. And that is why you can have, you know, a C# compiler, you can have F# compiler, you know, whatever compiler you want to pick, as long as you can turn it into MSIL, right? Then if you have the .NET runtime, right? You know, they ask you to install .NET framework. That sort of installs the components along with what we call a JIT compiler, which we can turn it into assembly, right? So this is, I hope you guys found that interesting, that there's garbage collector per process and not per machine. Okay. And I don't remember exactly, but do you know that the garbage collector is like around 500 lines of C++ code? I don't remember exactly, at least the initial version of the garbage collector in .NET was some 500 lines of C++ code. I'm like, I can't even comprehend how smart you have to be to like sort of think about this thing, implement it.
I got a 200 line one.
Huh?
I got a 200 line one on Git. I just don't want to share with the world yet to make this guy look bad. But, you know, just I'll let you guys know.
Isn't it just grab all, drag it to the recycling bin?
Exactly. See?
So we will say 200. I actually wanted to say 200, but I just think too low, so I made it 500 actually. But yeah, but think about it. It is amazingly mind-blowing that It's just a 200 lines of code. And the way to think about this is like this, right? Let me try to do it a little bit differently here. So when you have your .NET assembly and when it actually runs, right? Parts of it are like, this is your code. This is your code. And then what runtime adds for you is GC, type verifier, right? JIT compiler code, right? Permission, right? I screwed it up. This is a better model to think about. So every time you run the program, this thing gets sort of plugged into your process and then it runs independently. And this is what is like, that is why it's called runtime, right? And this is your code. Does that make sense?
It does. JD, quick question. Does anything or any concept change between .NET Framework and .NET Core?
Beautiful question. Nothing changes in terms of the concept, right? And that is why now you can actually truly understand what's going on with .NET Framework and .NET Core, right? So when Microsoft originally started, right, this idea was great, MSIL, right? And that is why you had this thing called mono runtime. Someone implemented a runtime for Linux which understands this, that can run your code. So someone in mono implemented GC, someone in mono implemented verifier, JIT compiler, permissions. And then you were able to take your C# program and run it on Linux using a mono runtime. I don't know if you've heard the term, the mono runtime, right? So the question is all about how do you create a runtime, right? So when originally Microsoft came up with .NET Framework, right, they wrote a runtime which just runs on Windows, right? And they made a lot of assumptions about what the operating system's memory model is, this and that, and blah, 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 for it to work, right? But now if you really want to make any C# code run on Linux or any other machine, you need another runtime. So Microsoft took a step back and said, you know, why don't we write a new unified runtime which can run on any Linux or any machine, right? And in terms of runtime, when they originally designed, they made certain assumptions about Windows and they sort of, you know, made it very non-portable. So they said, you know what, forget all that we did in the past. We're gonna redefine the MSIL so that it's compatible across different operating system and all that. And we're gonna rewrite the .NET Core runtime, right? And now when you do that, now you have to, again, when you write the program, you have to understand that aspect of it, right? That, hey, what is that runtime capability which is available to me that can run across different machines, right? So the whole effort with .NET Core is to unify and create a new runtime, and that's it. And that's why if you were to take a program like this, right? A C# program like this, if you take a program like this, let me make it bigger. If you take a .NET program like this, right? A C# program like this, you can compile it with C# and target .NET Framework and it will work. You target .NET Core runtime and it will work. Because you are not really, you know, they have maintained those constructs for you, right? But for example, let's talk about, say, directory class, where you say, hey, directory.enumerate files, and you say, hey, I want to go and find all the files in temp folder. Now, whatever the runtime and the base class library set up, it was not designed to be portable. So now, you will have to compile it and target the .NET Core, and then it will understand. In some cases, and right now I can't think of an example for you guys, but in some cases you can write a code which depends that it is part of .NET framework on Windows only. It's not part of .NET Core. So when you have that code, you can just recompile. Compiler will give you error saying, oh, this code, that doesn't work, because I cannot translate that into something that the runtime will understand. So is it making sense where .NET Core is coming from, guys? Right? Now, oh, by the way, I forgot to say one thing, that is, if someone can take notes at a high level as to what we are talking about, so that I know what is covered and what is not, that will be very useful. And now let me introduce you guys to the most amazing thing, which will really demystify everything and help you sort of really go to the next level, right? So there is this link called sharplab.io. It's an online thing. You type a code, and then you can instantaneously see what does the IL look like, right? So these are the construct: class, public, auto, ANSI. This is the step, call, instance void, knob, return. Like, this is sort of mimics assembly, but not exactly. And the reason I'm bringing this up is that there are very few construct in MSIL. Okay, IL also just has a notion of a method, notion of a variable, something. And the beauty of C# language is that you can write something and it will sort of turn it into something into IL. And that is what I mean by compiler feature versus runtime feature, right? So if something is supported in MSIL, right, that's a one-time feature, right? Or garbage collector, if something is in garbage collector, right? But there are a lot of things that C# does for you which has no equivalent in MSIL. It's just that C# abstracts it away from you, translate it into something that MSIL will understand, right? So what is my favorite example on that front? My favorite example on that front is the classic property, right? So let's take a class called person, right? And we have all written code like, hey, public string name get set, right? There is no notion of a property in MSIL. Only thing MSIL has is fields and methods. Does that make sense? So here you will see this get translated into, oh, the C# compiler put out a field for you, right? And then it defined two methods: get name, where it loaded the field and it returned the field, and set name, where it set the field and then returned it. And apparently, they do expect this notion, This must have changed in recent times. When I had looked at IL, so don't judge me on this, guys, okay? When I had looked at IL, when I was learning all this, this was not there. But at the end, this is what does the magic, right? And in fact, if you remember, this was not how we started, right? It was like you had to declare a field, right? And then you will do name, and then you will say, hey, I'm gonna do this. Remember that?
Yeah.
Right? So here, it automatically defined that method for you in MSIL. And then compiler guys came along and said, why do you have to do this? Right? Why can't you write and I will automatically keep that backing field for you, because that's what the runtime needs, right? So this one has another advantage that you can also compare it against a decompiled C# code, right? So when you wrote it like this, a backing field, return it, set it. When you wrote this, compiler put a backing field for you and did the exact same thing that you did it by hand. And the way they do it, right? And this is a compiler trick where it will give it a name that you can never ever, which is not a legal C# name. And that is what ensures that if compiler is doing something for you, you can never access it, because then it will be problematic. Does that make sense? Right? So this is what I mean by a compiler feature versus a runtime feature. You need to understand what compiler is doing for you, and then you can write good code. Then you can learn more. Hey, what is really going behind the scene, right? And that is what always blows my mind, that MSIL is so compact. It hasn't really changed that much. The runtime hasn't changed that much. What is changing is they are making compilers smarter and smarter and smarter so that you can express your idea at a higher and higher level, and it will do all the grunt work for you.
JD, so a question on this. So looking at your example here, so the compiler, does it actually go through, are there two distinct steps where it, like, you type in the simplified C#, and like your example, smart name, it then goes and expands that to like the complete behind the scenes C#, and then from there it goes and builds the intermediate language code?
No. Compiler directly goes to IL.
Okay.
The beauty is, because IL is so structured, you can write a decompiler to get the C# back. So if you see here, right, it says decompile to C#. And if you want to JIT assembly, right, you can even get that information. And all this .peak and other decompiler you will have seen in .NET, right? In .NET world, there are a lot of decompilers, right? What they are able to do basically, what they are able to do is look at this and try to construct a C# class out of it. So think about, so this is where, you know, if you really want to master programming in your life, if you master compiler theory, you can write any program you want, any program. right? You master compiler, you're good for life, right? Because think about it. Someone wrote a program to read this and turn it into this. And someone wrote a program that turns this class into this. Right? It's all about, at the end of the day, a translation from some human words into something that machine can understand. And that's what we want to do. We want to think in a higher and higher abstraction level. We don't want to worry about all this thing, right? This is how, if you think this is sort of an equivalent to assembly, this is how back in 80s someone had to write code. Like this kind of instruction, which are like 3-4 letters. That is what they had to do.
Todd knows about it.
Right? So,
Hey, JD,
everyone,
quick question. So all the benefits that you mentioned that we get in that assembly block that you had, garbage collector, type verifier, permissions and all that, why still this hop to this intermediate language? Why couldn't they just offer all those benefits at the assembly code level? I mean, honestly, how many of us care to look at the intermediate language? Never. Why have it? Why can't those benefits be offered at directly the assembly code level and save the hop and the memory footprint and everything else associated with it?
That is an amazing question. Thank you, Pawan. I did not expect that kind of question. And luckily, I do know the answer, right?
Damn, JD, I don't code as much these days, but you know, I know things. Actually, this one I don't. That's what I'm asking, but go ahead.
It's a great question. Remember what I told you about this runtime, right? Now, let's take an example called type verifier, that it verifies that you can actually access this. Or let's say permission verifier, that, hey, you can actually access that this is a public method, right? GC needs to know that this variable is in scope, out of scope, and all that, right? If you were to directly do the assembly language, these guys won't know how to interpret that to do what they need to do. They need that information, right? Like there is nothing called public private in assembly. Then how can the permission amplifier can work? It cannot work. It needs that information to do what it's supposed to do. And that is why they implemented the JIT compiler, so that these guys know the context of what they need to do, and then everything gets translated into assembly. Does that make sense?
Yeah, yeah.
So again, guys, a lot of things I know also in a conceptual level. I wish I knew more detail, but I try to read about it and I'm like, this is beyond my ability, right? But conceptually, that's the reason. These components need additional information about your code to be able to do their job. Make sense?
Yep.
Perfect. So, so this is this thing, right? So let's sort of get rid of that, right? And then you will realize that so many things are actually just compiler tricks. Everyone knows extension methods, right? So let's write an extension method. Right, let's do this and then write a code. So now look at this. All it did was to switch the guy around. You called it person.test, right? All it did was It called the way you have already used to write helper methods, and it just switched it for you. It didn't do anything smart. Even I can write that piece of code for extension method. Right? There is no difference as far as runtime is concerned, whether you write extension method.test and then you write person, or, I mean, this is the only thing that MSIL understands, right? And then it's like, oh, you know what? I actually prefer to write it like this because it makes more sense, right? So now compiler just goes and switches it out for you. Right?
Yep.
Now, let's take a little bit more interesting example where, you know, it will finally start blowing your mind as to what's happening, right? Let's take a little bit more complex example of iterators, right? We have used the yield return keyword where you can write the iterator, right? So there is no concept of an iterator in the runtime. I can say yield return hello. And now you will start seeing the genius of this guy. It actually creates a class which implements IEnumerable string with the current method, right? And implements the move method. It literally wrote a state machine class which does what you told here in 2 lines. At least it blows my mind away. Right? You see this guy here? They move into the move next method, right? So if you are familiar with the iterator pattern, right, this is how you actually implement an iterator. But obviously this is too much work if I just want to yield 2 items. So then they said, you know what, why don't you just write this? Because this is all very mechanical, right? It is all literally just following a pattern and implementing that for you. So you know what, guys, I will do that for you.
Can you show the IL for this?
IL for this will be insane because, you know, like it's massive, right? It has gonna have everything that it needs to do. So the reason I showed you IL originally was just to sort of tell you like what are the concepts in IL. Like there's a concept called field, right? There is concept called a method, right? And there's this accessibility modifiers. But IL doesn't really have a notion of like a first class property concept. I don't know what this is, which we saw earlier, but IL only has fields and methods and class. So for you guys, I'm not suggesting that you start getting into IL, right? Even I know only this much, but I know what's happening. So conceptually, you should know. But going forward, as you sort of get into C# and as you see the C# 8 and 9 features, you can instantly learn the new feature by just going to this website and looking at what compiler does for you. Async await is very similar. It's all compiler trick. There is nothing called async await in runtime. Okay, so there is this new thing which is coming up called record in C# 9. Let's go to C# master branch. think they call it, so record is like a new feature which is coming in C# where you get a value type like behavior for a reference type, right? So if you see here, right, it's a class that C# will do a whole bunch of things for you. It will implement the get hash code for you. It will implement the I equatable for you so that, you know, when you create two objects, if the properties match, you know, you get the value type like behavior. I don't know if you guys understand that all the nuances between value type and reference type, right? But there is really a need for a reference type which has the behavior of a value type. So that's the new record type, right? And the beauty is the whole thing is implemented in the compiler, not in MSIL. They didn't change MSIL for this. It's just a translation, right? So compiler, runtime, right? Compiler feature is also called syntactic sugar, and give me lots of sugar, and runtime. And that is what the most amazing thing about this is, that if you actually look at .NET, right, and you look at MSIL history, it hasn't really changed as much. Whatever they defined 10, 15 years ago is still enough to build new capability on top. What we are constantly working on is compiler. How can we let users write something at a higher level and translate into this? Make sense? So I want to take a pause here. I can obviously go on because I love talking about technology. But any thoughts, comments? What did we learn? Anything that you guys found interesting, or anything you still want to ask about?
No, I think it's good. I like the fact that we're starting just with the evolution of like .NET, how it came to be with the other tools available at its time, and how it has evolved. It's good to know that the MSIL hasn't really changed. Most of the version changes have been compiler related changes. So I thought they were changing kind of both, all the cool stuff we're getting to see. But I see that given the distinction, why it offers you a lot of opportunity to kind of take it higher and higher, add a lot of stuff on the compiler side while keeping the core of it the same. How are you, over the next few weeks, do you have like an agenda in your mind? Do you know how you're going to cover some topics?
Yes. So what I want to do is, first, I want you guys to start playing and start looking at your code like a simple code, right? Couple of lines of code. For every feature that you know, go to sharplet.io and see what compiler did for you. So you start filling in, hey, what really happened, right? And then next topic I want to cover is link, okay? I want to show you how link is actually implemented, how they evolve the type system in an amazing way to make link possible. And we will write our own link methods, and I will sort of completely break it down so that it's like, oh, as I was telling Duke the other day, right? You will start seeing ones and zeros that the compilers are doing for you. So next week's session is going to be link. Most likely it will be 1.5 hours or something like that, because it will take me a little time to go through the details. But man, I mean, everything will get demystified. What is lazy execution? Why did they had extension method? Extension methods were actually added for link only, right? Every feature in C# is very deliberately added. So if you you saw my example, right? Why would they spend their valuable resource in just help you transform from extension method.test to be able to call person.test? What value did it add, right? And they didn't add it it was not there in C#1, C#2. But when the link came, they added that because they had to add it to support link. So I want to sort of go into link, and that's the next thing I've already thought about. Then when I come around that, I'll think about, okay, what is the next thing I want to cover? And then I would still want to cover some C# language features. And then we will start doing engineering discussion. That, oh, now you know the language, but that's not enough to actually develop a system, right? How do you do exception handling, right? How do you think about your code? How do you structure your code? How do you decide how many classes you're going to have and how all that fits in together? So my goal is to sort of cover the C# in-depth book in like 3 or 4 sessions. At a good, like, you will have to still practice, but like I can run down the core concepts like this. And then we will start doing coding problems, and everything will fit together.
I have a question about the record type. So that looks like a straight copy of F#'s record type, where it actually gives you the immutability right out of the box. So I assume if you try to set something, it actually returns a new instance of the record.
Exactly.
But a question about that though. So before the record type, and if you're not using F#, do you always design your class so that if you have to actually change something, it returns a new instance of the class? Is that how you kind of design your classes?
Right. Okay. So you can always do immutable type on your own. Who can name the most used immutable type in .NET framework?
String.
Thank you. Right?
Wait, what did you say? String.
String.
Hey, buddy.
String is an immutable type. It's a class, right? It's a reference type, and it's immutable, and it's there from day one. So there is nothing in MSIL preventing you from writing immutable type, right? The thing is, it's painful, right? And that is why F# was able to have immutable type way before C#, because it's the question of just agreeing on some syntax and spitting out some code, right? Now, obviously, as C# was evolving, immutability was not on top of the list, but now we have link, we have async await, we have coroutines. So now they are like, oh, let's now tackle the problem of immutability, right? And that is what amazes me most about the C# team and Anders is to design some core foundational concept back in 2004 that in 2020, 16 years later, you can add immutability in a most natural way to the language and it all still works.
So,
does that make sense?
Yeah, but what I'm saying is that you're kind of the way you do data model design or whatever, do you design your classes that way where it is immutable?
Not really, right? Because that's painful. So it's not something you do because it's a lot of work, right? Like when I showed you the yield keyword, right? We were not doing IEnumerable before, right? Lazy executed IEnumerable we didn't do before, right? You didn't implement a IEnumerable interface to write a lazy executed generator, because fuck, I have to like fucking 50 lines of code. I'm not gonna do that. I'm just gonna use list and I'm gonna use a for loop, add it to it and return that because that's easy, right? So right now I'm not doing immutability because, well, it's a fucking pain and I have to get shit done. But if doing immutability is as easy as doing yield return, well, I'll start using immutability because it leads to better program. Immutability is always better. Now that's a whole another discussion as to why immutability better. right? So if you take it as a face value, that is a good idea, right? It's the same thing, right? You want to eat healthy, right? But if you are to like fucking get the organic chicken from Whole Foods, come home and cook it, you're not going to do it. You're going to order that double burger from McDonald's because it's right next to your door. But if there was a Whole Foods in your building, then you're like, oh, I'm going to pick a salad up because it's very low friction, especially if the price is also the same, right? Everyone would eat healthy, nutritious, delicious food if it's easy. We don't do it because it's pain in the ass.
Oven strongly agrees.
Whole foods and vegetarian, baby. Woo-hoo! And Todd
But
too.
you see, right? At the end, the programs we write is the reflection of the tools we have available. And that is why my constant feedback to my team and everyone is, you need to have better and better and better and better tools so that you can write high quality systems with less effort. And that's why I don't touch language like Python with a 10,000 feet pole, because if you can't verify that my variables are named correctly, then I didn't do typo, then you are useless to me, right? I don't have time to fix typos. I want compiler to find my typos for me.
Cool.
Any other thoughts, comments?
This is good, man. It's yeah, it's like code porn. So that definitely keep these going every week. I definitely want to partake. Just a couple of things, JD. I don't know if today's session was being recorded. Do you have the option of recording the ones going forth?
Every session will be recorded. The Zoom meeting is configured that every meeting will be automatically recorded at the start. Because I did some sessions with my team in office and I lost them because I forgot to record. So it's taken care of.
Okay.
It's just that I recommend a join because then sometimes it's just very easy for you to pause me and ask me something and I can clarify. If you see it later, then it's like, oh, you will have to make a note, follow up with me and all that.
Got it. Okay. And yeah, once you have it, if you can make it available somewhere, I don't know how you want to, if there's a way to share it, but yeah.
YouTube, a private YouTube video as per Todd's recommendation, but it will be in YouTube.
Okay, that totally works. Okay, and one last thing, as we kind of go through the initial sessions and then start doing examples and design, like once you know the language, like you said, how do you apply? Could we also towards then, it's not exactly related to C#. I know you and I have talked about it. Could you do a session about DevOps too?
Sure.
Because I know you said you made a presentation at a bunch of places you worked at. You have a much, I think your DevOps CI/CD setup is probably the best that I've heard from most people that I've talked to. And I'm going through a lot of shit personally at work because of that. So anything I could kind of borrow or learn from here is going to benefit me and my team significantly. And so yeah, towards the end, not exactly C# related.
Oh, absolutely. We will cover everything. We will cover BCL, base class library, DevOps. We will also try to go over database and some of the concepts around how database fits into this thing. How do you actually design a system from end to end? That is, you use C# to write the logic, you use the database to store the data, and you have to now evolve the code, feature branching and all that stuff. I'll probably just do it individually with you guys because my team is already fully familiar, so they don't need to attend the session at all. But I can show you, you, Todd, and Duke, like how in my team, I have 8 developers all working independently and seamlessly. I can show you how to set up that process.
Cool.
And that's why I put the meeting title as software engineering using C#. So we'll just engineer a software system together.
Sounds good. So yeah, no, from my side, this was great. Thank you for letting me partake.
Absolutely. Akshat, Ritesh, Sushir, Sudhir, good. Any questions? Like basically for Akshat, Sushir, and Sudhir, right? Like the reason I'm taking all this mainly is that I need to see the high quality code that I want. Okay. No, like, hey, I just wrote the code. I don't know why I wrote it, but I wrote it. That's not gonna work once we go through that, right? very deliberate. Every single character has to make sense. And you need to know what happens to that character and be able to visualize what happened at one time. That there is a garbage collector per process and not a system-wide garbage collector. And even though we started saying C# though, by the way, once you really understand it, you'll be able to translate it into different languages. You just will have to map those concepts. Like, wait, what happens in Python? You will be able to relate to it if you understand this word. Okay, so we'll keep it at here. 1 hour, 5 minutes. Actually, exactly 1 hour because we started at 11:05. All right?
Yeah. Hey, JD, one last thing. Next week, after you're done with the first 50 minutes, the last few minutes when we discuss miscellaneous items, one of the things, if you could, I know you spoke about it, you already told me this, but there's been this notion for several years that because of this intermediate language, C# takes a hit in terms of performance. Obviously, over the years, they have kind of fine-tuned it, and now, be it, I don't know, comparison with C++ or with Python, which is interpreted, it's not the case. You run a loop for something, you see the performance almost being comparable, and in some cases even better. So if you could kind of talk about that next week, not right now, but just
no, we can even talk about that right now. So that's a complete myth to say C# is not equivalent to C++, right?
Right.
Remember that step of JIT that I told you?
Yeah.
C# has a loading penalty. The first time you run it, it has to do a just-in-time compilation. That takes time. But then it's all assembly. And that's why when you do benchmarking of C#, you have to what we call warm up. So do some iteration without benchmarking it so that everything is JIT and all the assembly code is generated. So they didn't really do anything to that effect. It was always fast. It's just that you have the just-in-time compilation penalty. And that's where .NET also offers you like something called NGen, where it can JIT everything beforehand for you.
Yeah, I think I may have read about it. Yeah.
And so it is complete myth that C# was ever slow. It was never slow. Runtime was.
So it's just Duke's code is what you're saying.
Yep, it is Duke's code.
Fair enough. Fair enough. That's it. Okay. All right,
Anything
guys.
else?
This is great, JD. Good for this week.
Good. All right, great. Awesome, guys. Thank you,
Cool,
everyone.
man. Thanks, JD.
It was great, JD. Thank you.
Bye.